In this video, we are going to learn the user distribution feature of ProModel. This feature is used when in our model, we have some random variables. These random variables can be interarrayable times or processing times or group size, anything. We have some random variables. And in these random variables, the distribution of the random variable does not fall under any one of those known categories like normal distribution, uniform distribution, exponential distribution, etc. We know the probability mass function or probability density function of the random variable. Maybe with using some historical data, we have been able to put together that probability distribution, but it doesn't fall under any one of those known categories. Now we want to see how, using the user distribution feature of ProModel, we can define those distributions ourselves. To get a better sense of this feature, let's go to one example. In this example, we are going to look at a burger shop. So in this burger shop, customers come to the system. They go to the incoming with capacity of infinity. And then from there, they go to the server queue and then to the server. At server, they place their order, they do the payment and so forth. And then from there, they go to the dining area to eat their food. And in the dining area, we have 6 parallel tables that these customers can use to eat their food. And then after that, they leave the system. So the server queue and incoming queue have capacity of infinity. Server queue has also first in, first out queuing rule as well. The rest of the locations have capacity of 1. So there are a couple of things we know about this model. Customers arrive to the system in groups, and the interarrayable time of customers has an exponential distribution, average 15 minutes. And one thing we know here is that the probability mass functions of the size of the groups that come to the system. So as we said here, customers come to the system in groups. The size of the group is not fixed. I'm not telling you that the customer always come in group of 4 people. It's not fixed. I'm not telling you that the size of the group is random and has, for example, uniform distribution between 4 to 6. That's not the case. This table shows all we know about the probability mass function of this random variable, which is group size. The group size gets 4 possible values, 1, 2, 3, 4. And here in this column, I have the probability of each one of those possible values. The group size can be 1, 40% of the times. It's group of 2, 30% of the time. Group of 3 people, 10% of the time. And group of 4 people, 20% of the time. Okay, so this table has perfect definition or perfect characteristics of a probability mass function. I know all the possible values of that random variable. I know the probability associated with each one of those values, and the sum of the probabilities add up to 1. So this is a perfect probability mass function of a random variable. But as you can see, it does not fall under any one of those known categories like normal distribution, exponential, or uniform, or triangular, or anything, right? So we want to see how we can use the user distribution function, user distribution feature of ProModel to define this distribution, and then to tell ProModel that the group size in the model comes from this distribution. Regarding the time to place the order at the server, also that time is also random. However, this is all I know about the probability density function of that random variable. The possible values for the ordering time at the server can be between 3 to 4, 35% of the time, between 4 to 5 minutes, 35% of the time, and between 5 to 8 minutes, 30% of the time. Okay, so these are the possible values, and these are the probabilities. If the ordering time falls in this range, the probability is 35%. The probability of the ordering time falling between 4 to 5, 35%, and so forth. And similarly for the dining time, for the eating time. The eating time is also random. And this table shows all I have or all I know about the probability density function of that random variable. It can fall between 10 to 12 minutes, 30% of the time. it can fall between 12 to 14 minutes, 35% of the time. And finally, it can fall between 14 to 16 minutes, 35% of the time. So these are the possible values and the probabilities of the dining time in this model. So as you can see here, I'm dealing with 3 random variables: group size, the time spent at the server for ordering, and the dining time. However, these 3 random variables, each one of them has its own distribution, which we have defined in this table. We want to use the user distribution feature of ProModel to define these distributions and to tell the model to use these distributions to reflect those times in the model. So we define the locations. As I said, incoming and server queue have capacity of infinity. Server queue has first in, first out order. And for these 6 parallel locations, which represents dining tables, I use the first available rule for allocation of the customers to these tables. That's first available. Again, this is not the point of this model, but I just mentioned that so we get similar numbers at the end when we run the model. The entity that we have is customer, and then the arrival. So for the arrivals, customer goes to incoming. And the quantity each, the group size is coming from that random variable that we define, right? So to define a user distribution, we go to the analysis menu. You see here, analysis menu. And when you click on it, you see the user distributions feature. So click on the users distribution feature. Here we can define the name of this distribution that we want to define. I'm going to call it as group size. Okay. And then here when you press enter, the rest of the rows is filled automatically. So here for the type, if you click on the type, you see the possibility of defining this distribution to be for a discrete random variable or for a continuous random variable. Here, group size gets 4 possible values, 1, 2, 3, 4. So obviously it's a discrete random variable. So I'm going to leave it as a discrete. For the cumulative, I'll talk about it a little later. And then here for the table, if you double click on it, then this table tab opens up where you can define the distribution here. Okay, so here is where for us to define the possible values that this random variable can get and the percentages associated with each one of them. Okay, so here the 4 possible values that group size can get is 1, 2, 3, 4, and the percentages associated with each one of them are the ones that we can list here. As you remember from the table, group size 1 appears 40% of the time, size 2 30% of the time, 10% and 20% of the time. So when we put the values percentages here at this column, just make sure that you do not put them in the form of probability. We should not put 0.4 for number 1. I have to put 40 because this is percentage column. So when I put 40, the ProModel automatically considers that as 0.4. But here we have to put numbers in terms of percentages and not in the form of probabilities. Okay, so the number 1 would happen 40% of the time, 2 will happen 30% of the time, groups of size 3 happens 10% of the time, and groups of size 4 happen 20% of the time. Okay. So then here for the cumulative, the options obviously are yes or no. So no means this is just the probability mass function. Is not, these percentages are not cumulative percentages. However, if I choose this as yes, if the cumulative is yes, then these percentages have to be cumulative. So in that scenario, when for number 2, I have to put the cumulative percentage, which is the sum of the percentage for number 2 and the previous number for number 1. So then for number 2, the cumulative percentage will be 70. And then for number 3, I have to put the sum of the probability associated with group size 3 and everything before that. So for group 3, this will be 80. And finally, for group size 4, is the sum of this 20%, which is associated with group size 4, and the 80% that represents everything before that, and it's going to be 100. Okay, so that would be the, if I'm going to put the percentages in cumulative form, then this is how I'm going to put them. However, for this example, I don't want to define this probability mass function in cumulative form, so the cumulative is no, and I'm just going to, for each one of those possible numbers, I'm going to put the probability associated with it, or the percentage associated with it, not the cumulative percent. Now I'm going to go back to arrival and use this new distribution that I have arrived to identify the quantity each, or the size of the entities or the customers, or the size of the group of entities or customers that come to the system in each arrival. So I'm just going to copy the name of this distribution because I don't want to retype it, because always when you retype things, there is a chance of typo. So I want to prevent that. So I'm going to just copy the name of the distribution, go back to home, go back to arrival. And here for the group size, or for the quantity each, I'm going to use the name of this distribution that I just defined, group size, and then open parentheses, close parentheses. That's all I need to do. When simulation gets to this point, ProModel will automatically go to user distribution, find the distributions that we have defined, and use the values of that distribution to find the size of the group that comes to the system in each arrival. And then for first time, I'm going to use 0. The customers can come to the system from the start of the simulation. For occurrence, I'm going to put infinity. The customers can come to the system for as long as I run the simulation. And for frequency, it's E15, as we showed earlier. These groups come to the system with inter-arrival time of 15 minutes, exponentially distributed. Okay. Then let's go to processing. So for the processing in the tools, I'm going to pick the customer. So the customers who is already at incoming, from there they go to server queue. From the server queue, they go to server. From the server, they go to dining. And finally, from dining, they go to exit and they leave the system. So obviously at incoming, there's no way processing time. When they go to the server queue, there's just waiting time that is calculated in the system automatically. However, when they come to the server, as we mentioned here, the time to place the order with the server is coming from this distribution. These are the possible values that the ordering time can get between 3 to 4, 4 to 5, and 5 to 8. And these are the probabilities associated with each one of those possible ranges, 35%, 35%, and 30%. So now, again, I have to go back to user distributions and define this new distribution, which, as you can see here, this is ordering time. And the time is a continuous random variable. And here, even when you look at the range of values, anything between 3 to 4. So obviously, between 3 to 4, anything, those are continuous random variables. So I'm going to define this new distribution for ordering time. And on ordering time is a continuous random variable here, as opposed to group size, which is a discrete random variable which we define in the group size distribution. So let's go back to user distribution analysis, user distribution, and now we want to identify a new distribution. So this new distribution, when you press enter, a new row is created. So I'm going to call it ordering time. And this ordering time is obviously for a random variable that has continuous distribution, is not discrete anymore. And here is the table tab is open. If it's not open, you can always click on the table here and this tab is going to get open. But here the table tab is open. So here I'm going to define the distribution. Let's go back to the distribution one more time. So as you can see in this distribution, for any value less than 3, the chance of happening is 0. So the values less than 3 cannot happen for the dining time. So here I'm going to say that for any value 3, less than 3, the percentage will be 0. The way that ProModel is going to interpret this row is that to say that for any value less than 3, then the percentage of happening is going to be 0. And then for values between 3 to 4, is the percentage is 35. Okay, so the way to do that is that in the next row, I'm going to put 4 and for the value, and then the percentage is 35. So the way that ProModel interprets this row is that for any value less than 4 till previous, so till the value identified in previous row, any value less than 4 till 3, the percentage is 35. Okay. And then for any value between 4 to 5, the percentage is 35 as well. So the way to do it is to create a new row and then put 5 here to tell the ProModel that for any value less than 5 till the value in the previous row, less than 5 till 4. So for any value between 4 to 5, the percentage is 35. And lastly, for any value between 5 to 8 is 30%. So between 5 to 8. So in the last row, I put 8 here in the value. And again, ProModel interprets this for any value less than 8 till the value in previous row, which is 5. So any value less than 8 till the value in previous row, which is 5, means between 5 to 8. And then we put the percentages in the row associated with 8. So for any value between 5 to 8, the percentage is 30. Okay. So that's how we are going to identify the distribution associated with this continuous random variable. While we are here, let's also define the distribution associated with the dining time. So the possible values are from 10 to 12, 12 to 14, 14 to 16, and we know the probabilities associated with each one of them. So if we want to define this distribution, what we are going to do is to go back to user distribution again. Press enter to define a new distribution. I'm going to call this distribution as dining time. And again, dining time is a continuous random variable. So this distribution is going to be used for a continuous random variable. And for the table, and here is the table tab to define this distribution. So what do we know about distribution? Any value less than 10 is not going to happen. So there is 0% for any value less than 10. So here I write 10, and then here I put 0. ProModel will interpret that for any value less than 10, percentage is 0. Next, for any value between 10 to 12, percentage is 30. 30% between 10 to 12. So next row, I put the value 12. The ProModel is going to interpret that for any value less than 12 till the value that we see in previous row. Less than 12 till 10. So for the value between 10 to 12, the percentages is 30%. And for any value between 12 to 14, 35%, and 14 to 16, 35%. So for between 12 to 14. So if I want to identify the values between 12 to 14, I'll go next row. Here I put 14, which means for 14 and any value less than that till the previous, till the value of previous row, which is 12. 14 till 12, which means between 12 to 14 is going to be 35%. And lastly, for any value between 14 to 16, any value between 16 and less than that till previous row, which is 14, any value between 14 to 16 is going to again be 35%. Okay. So that's going to be the distribution for the continuous random variable that shows dining time. Now that we defined these two new distributions, let's go back to the processing and use these distributions to capture the processing time. So I copied the name of this distribution just because I don't want to retype it. I go back to home, processing. So now here for the server time, I'm going to write it as we always do, wait. And then for the time to place the order at the server, the value of that random variable comes from this distribution, order time. And all I need to do is to open parentheses, close parentheses. And then for the dining, I'm going to use the other distribution, which is the dining time. And if I go back to the processes, So here again, to capture the dining time that takes for them to eat their food, I will put weight as always, and then the name of the distribution, open parentheses, close parentheses. So with that, when the simulation gets to these lines, simulation will automatically go to user distribution, find these specific distributions that we have defined here, and use those distributions to generate random numbers that are going to represent the server time, the time to place the order, and then the time to eat, the dining time. So with that, we define 3 user distributions and use these user distributions in the model to capture the group size when they enter the system and to capture the server time and the dining time. Now we are ready to run the model, but before we run the model, I want you guys to make sure the default unit of time in your model is minute, because I did not put the unit of time next to any one of these distributions, or where we had, for example, our interarrival time. All these times are in minutes. So make sure default unit of time in your model is minutes. And then we are going to run the simulation. I'm going to run this simulation for 100 hours, and that's what we get. So about 860 customers got the service from this burger shop and left the system. And here you can see the percentage in operation of each one of those dining tables. And as you can see, because we use the first available rule for allocation of the customers to these dining tables, obviously the first one has highest percentage in operation, and then the next one, and the next one, and so forth. And here, if you go down at the end, the option dining that you have shows the average across all these 6 tables. Okay, so this the user distribution feature is a great feature to know, because then you can define some distribution for the random variables in the model that are not among those already defined distributions like normal, exponential, uniform, and so forth. But still, ProModel gives you the possibility to define those distributions and use them in the model.